So, hello everyone. Let's talk about today's Geeks for Geeks problem again. So, the problem is very easy and simple. So, let's see what is the problem is saying. So, you have given an binary tree and you have to tell it is a maxip or not. Okay. Now, what is the condition of maxip? What is the maxip? They are mentioned here. So, every level of the tree except possibly the last is completely filled and all the nodes are as far left as possible. Okay, it might look the confusion. I'll explain in a very simple manner. And the second is a maxi property. The value of each node is greater than or equal to the value of its children. Okay, so it's simple. It's the explanation of look might be little bit confusing, so I'll explain in a very simple manner. So what is the condition of maxi? Okay, so I'll explain the maxi condition. The first, it will consist, it is a complete binary tree. Okay, the tree should be the complete binary tree. Now, what is the complete binary tree? We'll look into it. The second thing is a parent node value is greater than a both child node. If there exists both child, then if there is no exist, so I'll just take the parent node value is greater than child node value. So what is complete binary tree? We'll look into here. So this is problem is combined. You have to check first the complete binary tree, and you have to after that you have to check the parent node values is greater than child node values for all the test cases. So what is the complete binary tree? So complete binary tree definition very simple. Each node have at most two child node except leaf node, and if you are talking about leaf node, it is filled from left to right. So there is no null between. There is no null node between any not null node. So let's see with the example. Okay, so I'm trying to draw one complete binary tree. So this is a complete binary tree. Okay, let's see. Okay, so this is complete binary tree. So what I'm saying, if you remove this node, it will still a complete binary tree. Okay, if you remove this node, it's still a complete binary tree. Why? Because this is the last node, which means it's a leaf node and it start filling from left to right. Okay, and there is no null between any not null node. What is meant by no null node between the not null nodes? So let's see. Okay, so this is not a complete binary tree. Why? It started filling from the left to right, but there is a null node between before a not null node. Okay, so it will not get accepted. It violates the complete binary tree condition. If you do something like this, it's still not a complete binary tree. Or if you have something like this, okay, like here 8, so it will still not a complete binary tree. Okay, so this all of the condition of the complete binary tree. Now the second condition is maxi property. What they say, each node value is greater than its children node. So I'll say the parent node value is greater than equal to child node. So suppose there is a tree with value a, b, and c. So what is the simplest means? A is greater than equal to b, and a is greater than equal to c. This is the simple maxi property. Okay, for all node, for all node. Okay, so if there is any node like d and e, so b is greater than equal to d and b is greater than equal to e. Now if this condition is satisfying, like a is greater than b and is greater than c, so this condition is also getting satisfied. So you have to check only for the upper node, or you can say the ancestor, the closest ancestor. Okay, or parent node. You have to check only with the parent node. You don't have to check with the upper nodes. Okay, so this is all about this is the maxi property. So before solving this problem, you know about what is the complete binary tree. Okay, if you solve this complete binary tree problem, then this is problem very easy for you. So what I'll do, I'll solve this problem for you, and after that complete binary tree. So this problem is dependent on the two problems. You have to first check the complete binary tree, and after that the second max value. So max value property is very easy. The complete binary tree is bit, it might be a confusing. So let's see, there is a 2 or 3 approaches to solve this problem, but I will see very simple problem. simplest approach. So this is a complete binary tree which we have given. Okay. Now what I'm saying, if there is any null node before, if there is any null node before any not null node, then on any level, okay, I am telling on any level. So if you are talking about level by level, so we have to do the BFS, which is level order traversal. So we'll do the level order traversal. And so what I'll write the snippet of level order traversal, and then we'll discuss further on. This is the problem of complete binary tree. So let's see what I'll do. I'll take a one q, okay, q dot push root node. Okay. So I'll just check. Okay, I'm checking if there exists any null node before not null node. So I'll take one more variable for the null check if null present or not. Okay, why I'm checking here? I'll explain. Is null present? So it's false. Why? Because there is no null present. Now while not q dot empty. Now what I'll do? I'll calculate the size, which is q dot size, and then for int I is equal to 0, I can n and I plus plus. Okay. Now I'll just extract the current node. So what I'll do? Node star f is equal to q dot front. If f is equal to null, or you can write something like this in C++, not equal to f. So if f is null, then what you just say, is null present? Yeah, is null present is equal to true. Okay, nice. Else, if it is not null, just check. If null is true, then return false. Else, q dot push root left and q dot push root right. Now, if this all condition is satisfied, return true. So let compile it. Okay. Now the question is why I'm taking this as globally. So uh, it gives the TLE because I'm not copying all the elements. Okay. So yes. Okay. So it again give it TLE. I'm not sure about this why it's going to TLE. Okay. I'm not. Okay. So n is equal to q dot size, then q dot front and q dot push root left, then q dot push root right. Return the true. Okay. Return false. So it won't give a TLE, right? But I'm not sure why it's giving the TLE. Okay. So instead of root, I have to use f, okay, because root is already cancelled. Okay. Okay. So now if I submit it, it will get accepted. Yeah. So it will get accepted. Nice. So the question is why I'm taking this. Okay. And so basically, this is the thing I'm saying. If you encounter any null value, which I'm checking here, okay, if the f is equal to 0, I'll make is null is equal to 2. Okay, is null is equal to 2. Okay, now on the else side, if f is not equal to null, means there is a value, node value. Suppose this is the node value. So what I'm just, I'll checking is null is true. That means there is any null value before this not null value. If yes, then return false. If it's not, then return true. Now it will get accepted for this. Now why I am declaring this as a global? So there is a one test case which I also not noticed. Once I get a wrong answer 4 or 5 times, then I notice that problem. Okay, so this is a null, and after that I'm just doing this. Okay, so if I will use is null inside this loop, like before this loop, then it will give the wrong answer. Why it will give the wrong answer? Because for this level, this null will be the false. Okay, and according to level by level, it is condition is getting satisfied as a true. Why? Because I declare this here, but this is not a complete binary tree. Why? Because this is not a last node of this tree. So that's why I declare it as a globally. Okay. Why I declare it as globally? Okay. If this is not a last level, and once it will become a false, once it will become is null become a true. So if this come here, it will check the node is not null, but is null is a true. Okay. So it will return the false. But if I add this on a level, so it will also means it will become a true for, but this level it will become a false because it is updating on each level. That's why I declare this as global. Okay. So once you get is complete, so now your next target is finding is max property. Okay, maxi property. So what is maxi property saying? Suppose you have a tree like a 97, then 36, 34, then here 32, 31, okay, and here is a 24, something like that. So what I'll just do, I will do the pre-order traversal and I'll pass this 97. So I'll check 97 is greater than 34. Yes, it is. So what you just do, go next and check for this node. So 36 is greater than 32. Yes, it is. Okay. And 36 is greater than 31. Yes, it is. So it will return a true. Okay. Now here also 97 is greater than 34. Yes, it is. And then 34 is greater than 24. Yes, it is. So it will return true. Now from both side, if it getting true, t and t, then answer is a true, else answer is a false. Why? Suppose here is a 54. Here is a 54. So 34 is greater than 54. No, it's not. So it will return a false. Even this is following the maxi property. Even this part is following the maxi property, but this is not following. So if this is a false and this is a true, what I'll just do, if t and false, the answer will be the false. Okay, so I'll use the AND operator because the condition satisfied for the both cases. So this is also the very easiest part. So let's solve this problem. So I'll just copy this code. Okay, so I'll just copy this code. Now the first part is check the tree is a complete or not. So if is complete BT and tree. Okay, so the further check is maxi property. So I'll just written is max heap. Okay, is maxi, and it will go with the tree and the maximum value. So for the root it will come in the max. Okay, now if it is condition is false, then return a false. Okay, bool is max heap. Okay, node star root and integer max value. Okay. If not equal to root means root is empty, return true. Okay, if root dot data is greater than means is greater than max value, then return false. Why return false? Because I already told the max value is greater than root data. So I'll just reverse it up. Else return, or you can write instead of making it confusing. I'll just do yeah. So I return false here. So now what I'm written here, I'll return is max root left and root data and then root right and root data. Okay, so it is correct, I guess. So this is complete BT. Let me check. Okay, so if I compile it, Yeah, it is passing all the test cases. So if I submit it, I hope it will get accepted. Yeah, so it will get accepted as well. Okay. So this is all about today's problem. I hope you understand the problem very well. So goodbye for today. Let's meet tomorrow. Bye.